all the time. So, growth and decay, okay? When something decreases or grows exponentially, like I said, huge or really small in a hurry, but here's the catch. Repeatedly multiplied by the same number. In other words, maybe I'm going to be doubling something. Maybe I'm going to be increasing it by 50% or something, but it's going to keep doing that. So, I mean, we're going to have some actual life applications, like how much does a car depreciate when you drive it off the lot? Or, you know, when the population increases over time, you know, how does that affect things? Because those things are things that, you know, come into play in government and everyday life type things. So if something's growing, we've got this really funky looking equation here, this y equals a times b to the x. And basically what we're doing here, the biggest thing to note is right here. My b value, this value I'm taking to the x power, and I'll explain how the x power works here in a second, is always going to be greater than 1. Now, it doesn't mean it can't be a decimal or a fraction. It just means it has to be bigger than 1. It won't be a fractional, as in like between 0 and 1. So whatever we start with as a, might be some money, okay? It might be money. It might be a number of something. We may have bacteria if we're working with a science type thing or something like that. But there'll always be some value that we're starting with. So that's going to be my a. B is what's called my base, okay? And again, like I mentioned here, it's got to be bigger than 1. And it's called a growth factor, okay? And what I wrote over here to try and help out is, basically, I'm taking what it says here. It'll be a percent, and you must add 100 to it. Well, 100 as a percent is 1. So we'll do 1 plus some number. And we'll get into that when we actually get into the problems. And then x is the exponent, usually a length of time. If they tell us to do it for 3 years, we can plug in a 3. If they want us a bunch of years, we can use x and let the calculator help us. So here's how this is going to work. All right, John bought 3 fish. Simple enough. Okay, this would be the equivalent of my a value. The salesperson at the store said they would double in number every month. Complete the chart below to show how many fish John has each month and then graph it. So we're going to visually see what it is, and then we'll let the graph kind of see how this is going to work too. So John starts in his first month with 3. And then doubling means you just times it by 2. So the second month he's got 6. And he's got 12 because I keep doubling it. And then I stick another times 2 on the end to double it. Yeah, when we get to month 4, we're going to be all the way up to 48 already. All right, yep, 2 for 2. So, right. Now, instead of having to write all of that out to figure out the 48 that I'm going to be getting here, what I can do as I go month to month is just take the prior month, which is all of this stuff, and just times it by 2. But then it gets kind of interesting, because you're like, wait a minute, number of months, n? What's that supposed to mean? Well, basically what that means is, what if I wanted to find out, you know, in month 121 how many fish there were going to be? That's kind of a scary thought. So what we can do here is we can say, okay, well, what did I start with? We said our a value was 3. Then, let's see. My growth factor was doubling, which would be 200%. So I'd have 2 to the x, and that actually would end up being what goes into my calculator if I wanted to have a bunch of these show up at once. Now again, this is going to be something that's going to take a little time to get used to, but here's how this is going to work. Once I get the calculator on, I'm going to go to y equals, okay, because we're going to graph this. So once I get to y equals, this little formula that we just got going here is what I'm going to type in. So I got 3 times 2, and to get the exponent, remember it's just this little up arrow. So 2 to the x. So that's what this equation would look like on the calculator. Now the thing that gets kind of funny is, if I go and hit graph, let's say I want to look at it. So you'll get something unless somebody's messed with your window. If they have, let me know. We'll get the window up here so we can see what we're looking for. But it looks like it's just kind of curving upward, and that's the idea of growth. It starts out kind of small, and all of a sudden just bang, there it goes. Okay? So, well, how would I know, where all these numbers are going to be? So if you weren't sure, or if you wanted to see the numbers, if you hit second and graph, you'll actually get to see all the numbers that we just figured out manually. And that's why I said the calculator is so neat with this. Because now instead of having to manually crank all this out, I can just look at my chart and say, oh, 0, 3, oh, 1, 6, 2, 12. And if I were to ask you, after a year how many fish there were, instead of going one by one, you just go down to 12 and say, dang, after a year there'd be 12,288 fish. That's insane. Open your own aquarium. So you're like, okay, but for the time being, I've got all my info and I want to graph this, so what am I going to do? Well, I guess the easiest way to start would be to start labeling my months here along the bottom. I'll just go out to 6. 5 even would have been enough here. But now the number of fish, that's a dilemma because my chart goes all the way up to 96. So I don't have 96 lines here. So what might be a good idea to count each line as so I can actually fit some of these on here? Instead of making each line worth 1, maybe what could I make each line worth? We could try, but I still think if I did 2, I still think I'm going to need about 50 lines, and I don't quite... 10. Okay, let's try 10 out. So 20, 30. So if we did each one for 10... And again, there's not a right way to do this. It's not like, well, you have to do it this way or else. As long as it can fit on your graph, okay, try something out. So then when I go to plot them, you're like, ooh, so 0, 3, well, that's not quite 10. So we got to put my dot between the 0 and 10 here at 0. So after 1 month, let me get this out of the way, I had 6 fish, so I'm a little over halfway there. After 2 months, I had 12, so I'm a little above the 10. At 3, I'm at 24, so I'm between 20 and 30, and you start to see it going up. 4, I'm all the way up to 48. 5, I'm all the way up to 96. Okay, and just by that, I can look and say, okay, that's my graph, and that's what growth looks like. It get really big in a hurry. I mean, when we went to look and see after a year, that 96 became over 12,000. Ooh, the power of compounding something. Hopefully it's something good, though. But that's how any of these would work. So what we're going to do...
It doesn't look anything like a graph.
Well, let's... It does a little bit? Yeah. So what you'll start to notice is if something's growth, it's going to start going up to the right in a hurry. So what we're going to do is, since it gets boring just plugging in numbers and looking at the same type of graph, we're going to start getting some actual applications in and kind of work with this. Okay, sure. Okay, now if it was 3 to the 2, 3 squared, it'd be like 3 times 3. So that actually ended up being tripling it. And then when I got to the next one, if I did 6 times 6, and types. Well, just kind of think, maybe instead of double, maybe think of it as twice as much. Because if I start thinking about it like money-wise, if I have $5 and say I'm going to give you twice as much, well, I'm going to get 10. Well, if I have $10 and I get twice as much, now I'm going to have 20. Because here, this x, 3 is what I started with. Because when I do these, this is the formula that I'm working with. So 3 is what I start with. The 2 actually is coming from, you start with 1. You start with 100%. Well, and if I'm doubling it, I'm adding another 100% to that. And when we're doing percentages, 100% just equals 1 because we moved the decimal point. So 200%, which is what double would be, ends up being 2.0 or just 2. That's where the 2 is coming from. And then x just allows me in a general way to say I can find out how many fish are in any month. I just would plug that value in. So if I want to know how many fish there were in a month, like a year, let's say, I could plug in 12 for x. If I want to know after 5 years, I could plug in 60. So it's just kind of being really general, because the calculator, when we do it in general, will draw the graph. If I just put in a specific number, it'll just give me a line. It's kind of weird the way that works. It's just getting used to that a bit. Yeah, we don't have to have that. I just put that so you could kind of see that's what I was plugging into the calculator for that. Good questions. Yeah, it's stuff we absolutely are going to want to know. So, this next one, because we want to use this a times b to the x stuff that we've got working here. So then the next part says, suppose a new automobile currently costs $15,000. Okay, $15,000 is my starting amount. So I got y equals 15,000. The cost of a new automobile increases 5% each year. So here's how this is going to work. We always start with 1 plus when it's growth. And I know it's growth because it says it's increasing, it's getting bigger. How do you write 5% as a decimal? Okay, I thought I heard somebody say it. 0.05. Okay, and if you're not sure on that part, here's something that you'd be able to do on the calculator if you wanted to check for a second. Let me get out of this for just a sec. If you ever want to come up with a decimal for a percentage like we do here, take whatever percent it is and divide it by 100, and that'll give you the decimal form of that percentage. Because we're going to need decimal forms of percents when we're doing these. So once I have my equation, now I'm going to be able to go and get my answers for this. Now, do I have to put it in y equals? No. But let me show you why I'd probably look at doing that. Okay, let's say I don't want to. Let's say I'm just going to plug this in. The x, okay, the amount of years, bless you, is my x. So if I wanted to, I could just type, and this is how I could do it without having to use a graphing calculator. I could type that in, and when I went to do my exponent, instead of using x, I could just use the number of years that I want. So after 1 year, that same car would cost $15,750. Now the disadvantage I have in doing that is, now for every one of these that I do, I have to go back to the beginning, unless you have a fancy button on your calculator that lets you just go back and switch little parts. And I'd retype everything except my exponent would change.
And then you're, okay, so I got confused with that 1 plus the 0. You got that 1 because it was only 1%.
Yeah, you always start with 100%. You start with a full value, and that's what the 1 is.
Okay.
And then the plus part will just be whatever percentage they give me. And so what I would do is I could find out as I do each of these how much it's going to be. Now, some of you may like doing it that way. That's simple, it works, and you just kind of keep doing it. If you wanted to use the graphing function so you didn't have to plug it in every time like this, here's how that would work, and then you can do it whichever way you want. So if I decide I'm going to do the graph instead, so I'm going to hit y equals.
I got two different answers and you wanted.
Oh, let me get out of here for a second.
I don't know what I did wrong.
Did you get the little arrow button going up? Because sometimes I forget that.
Yeah, I got that one.
Let's let you get that in there one more time, and then we'll try the y equals here again. And we'll kind of see how this goes.
Yeah, I got.
All right, a second. We're going to pause. At the y equals part, just in case. Because again, the way you see right here is what you could do on any old calculator you ever have. Okay? You don't have to have a graphing one. But if you have one available, if we go to the y equals, we're going to plug this one in. And we're not going to put a number in for the exponent this time. So we're going to put this in here. And this time when I do an exponent, to get x, I hit this button right next to the green alpha button, because that'll be my x. Because then, watch this. This is awesome. If I hit second and graph, so I hit second and graph to get the table, you'll notice right away, hey, that table, when I go to x equals 1, is the same answer I got for part A when I plugged it in the calculator and just did it manually myself. Now the one difference here is when you go to the chart like this, it rounds. So like for instance in B, instead of having the 50 cents, it just rounded it up to the next value, $538. But the nice thing is now if I did it this way, when I get to C and D, I don't have to retype it in anymore. I just go down to, oh, if it's 5 years, my x equals 5. And I just write down the number that I see. For 7, instead of typing it all in, but again, you absolutely can, I just scroll down, I get the number. And I could even find out how much a car is going to be worth like in 30 years if I want to this way. So it just gives me some options. So plugging it in works. This part works. Okay? So I'm going to put this down for just a second. And what we're going to do is we're going to take another one that works similarly. Let's see if we can set this up. So again, with this, I start with 450,000 people. So that's my A value. That's what I start with. It increases, there's the magic word again, by 2.5%. So when I set this up, it's 1 plus when it increases.
You always put a 1?
Yep, always put the 1. How do I make 2.5% in its decimal form? Okay, we're close. Whoops, hang on a second here. I got to get out of here. Okay, remember, you can always take the percentage, divide it by 100, and whatever decimal you get there, that's what we're going to use. So this is my formula. And again, I have choices on how I want to do this. I can either take my equation and just type it in, make sure you get all the zeros in there, and then just copy what I see in my box here, but instead of doing it to the x power, I just do it to whatever number of years it says. So in this case, I'd do it to the first power, and I'd hit enter. And I'd see what the population's going to be in a year. So if you're more comfortable just kind of tackling this one part at a time, I'm saying, okay, yep, let me do this last one, and then we'll do the next one with y.
When I do y, it doesn't work.
Yeah, same with me.
Like
Okay.
a bunch of random numbers.
Well,
Like,
okay.
Way bigger than they should be.
Well, let's check this out and see what's going on here. We're going to round to the nearest whole person here because people aren't in parts, at least normally. Okay, so let's try out and see what's up with y equals here, because for some of you, I'd like you to have that option if you like that at all. So if I hit y equals and get whatever's cleared on there, whatever's there. All right, let's type in our formula here. So 450,000. 1 plus, make sure you get your 0.025 in there. And then instead of putting in a number for my exponent, I got to have my little up arrow, my caret, otherwise it doesn't become an exponent. So your screen should look just like that. if you are going to go this route. Now, I don't need to hit graph on this one. I visually will not be able to see the graph because the numbers are so big. So here's where I use second and graph, because that's going to get me the table.
Can we get 5 to
Now, if you're looking at 6, yeah, 521862.
yeah.
Yeah, okay. Because you notice when I bring the chart up, my answer, when I plugged in x equals 1, okay, I got the same thing. When x equals 3, I got 484,601. I got the same thing. So for those of you that were kind of like, before with what's going on, are you getting the same thing I am now?
Yeah, I didn't put my little carrot.
Yeah. I didn't
Yep,
know.
that can do it. It's little stuff can get you on these. So like with 6, instead of having to type all that in again, just scroll down to where x is 6 and write the number down. Okay, if I want it for 10, I just scroll down and write the number down. Okay, so again, whether you use the y equals and second graph, let me stress that again, second graph to get the table, or you do it manually like we did here, the answers are always going to work out right for you, okay? But it's just making sure that you get used to the formula. And again, with this being notes, you'll have access to this in all your homework and the quizzes anyway. So you'll always have that to be able to look at for an example. Now, if we flip over to the back, we're going to be doing the same type of idea, except now we're going to work with things that decay. Now, decay, that can be anything from trash to the value of, a house or a car, to investments, to all sorts of things. You're like, well, it looks like the same formula. It's a times bx. That's true. But here's the difference. Now, my b value is a fraction somewhere between 0 and 1, or it might be a decimal between 0 and 1. So now when that happens, instead of doing plus the percent, decay, I'm going to do minus the percent. So everything else is the same, except now I'm doing minus instead of plus, basically. Okay. So I look and I go, okay, let's see how this works. Jane has 128 flowers. She forgets to water them, and half of the flowers die each month. Well, that's not very good. Complete the chart below to find how many flowers Jane has each month, and then graph. So notice now instead of multiplying by 2, we're multiplying by a half. Or that's the same as taking your value and dividing it by 2. So instead of multiplying by 2, we're going to keep dividing that number. So you're like, oh, so like if this is 32, and I get to month 3, I can take that answer from the month before and divide it by half, or divide it by 2 in this case. And Jane's not going to have very many flowers for very long, because if we keep taking the answer from the month before and dividing it by 2, and dividing it by 2, we are going to run, oops, I got a little ahead of myself. I forgot the last one's n. So similarly to what we did before when we got to n, remember, here's how these work. Okay, what was my starting amount? How many flowers did we start with?
128.
128. Okay. So now, this time my decay factor, I kept going by a half, because the factor always has to do with multiplying. So it'd be times a half, okay, to the x. Now let's see if that works in the calculator. All right, let me bring this up. I'm going to get my y equals back up. I'm going to clear that out. And I'm going to type in what I'm seeing right here. So 128. For the fraction, I just used the divide button. So 1 divided by 2. And don't forget your little caret button, because otherwise you're not getting an exponent here. So 128 times 1/2 to the x. And let's hit, well, let's try graph on this one first, because I just want you to see what this looks like. Ooh. This one's not going up to the right, this one's going down. And that makes sense, because it's getting smaller and smaller and smaller as time goes on. But let's see if our chart worked out okay. So second table. Swing this guy over here. And I notice, yep, 0 is 128, 1 is 64. It's getting smaller, it's getting smaller, it's getting smaller. And I'd be able to figure out any value I wanted. So these match up. So when I go to graph them, it's sort of like that same dilemma we got ourselves into before. I can't fit all these numbers from 4 to 128 on my graph. So I think we're going to go with what we did before. And we're just going to go by tens. And that can change. Sometimes it may be 5s or 2s or whatever it happens to be. We're going to use up all of this time. So if I count by tens, I can make it up to 130 before I run out of room. So at 0, I'm at 128. That's awfully far up. At 1, I'm at 64. 2, I'm at 32. You're like, yeah, this is going down in a hurry. Yes, it is. 2, where am I at? 3, I'm at 16. 4, I'm at 8. And it comes from big and small, 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 small. But it's never going to go less than 0. I mean, you can't have negative flowers. That doesn't make any sense. So that kind of tails off. So when I do get to the bottom, the idea is going to work the same way. Just like it did on the front, except now when I go to make my equation, I'm going to use a minus. So whatever I start with, I'm going to do 1 minus, and there's my percent. So 2%, 0.02. And again, that would be to the x. So just like we did last time, we have a choice. Some of you seem to, I think, like the idea of plugging it into the y equals, because then you don't have to think a whole lot. Let's just type in my number. Make sure I get the right number of zeros here. 4,500,000, yep. So 1 minus my percent as a decimal. And don't forget that caret button to get my exponent to the x. Now again, if I tried to look at the graph of this, I'm not going to see it. It's going to be way out of my screen. So second graph, you're like, ooh, what are these funky numbers? What's this e to the 6 thing? How does this work? Let me show you something. That e to the 6 means you're going to take that number, we're going to lose the decimal, and we're going to add that many zeros. So you're kind of like, wait, what? Okay, so if you have, actually let me get down to the 3 that we're looking for here. So it says 4.24 e to the 6. Now what does that mean? What that means is I'm going to write the 424, and from here I'm going to go 1, 2. Okay, I'm just showing you how this kind of exponential thing works here. The e tells me there's decimal places, not like it's just 4.24. Because what I'm showing you is this point here. Here's how this works. That means I'm going to take that decimal point and I'm going to move it 1, 2, 3, 4, 5, 6 places to the right. In other words, I'm going to end up with adding 4 zeros onto it.
How did you get 6?
Straight from the chart here. It said E6. So it just tells me I got to add that many places to it. Now, some of you may say, ooh, I don't like this E thing. Is there a way I can get away from the E thing and not have to deal with it? Now, I'll show you one more, but then I'll just say, I can always go back if I want to. Because again, all that means is I would take the 4.07 and I'd go right 1, 2, 3, 4, 5, 6. And then I would just copy down the number I see without the decimal points. Now, like I said, if the E is just something you're like, that is going to mess me up, I'm not going to remember it longer than you just talking about it here for these 30 seconds, here's my option. Okay, if I get back to the regular calculator, I can, just like we did before, type in my number, type in what I have in the parentheses, but instead of doing to the X, I do to the number of years. So let's say we're doing C and we want it for 10 years. I can hit enter and the calculator will just tell me what that value is. And again, I don't need, whoops, I almost wrote it down wrong myself.
Adding, I'm going to do the, like the Y thing. This one.
Yeah, because since we're decreasing, this is why, yep, I'm having to minus instead of add on this. But I can just round off and do it that way. So if the E is something that bothers you, this whole scientific notation thing is a bit too much to deal with everything else that we're doing. I just type it into the calculator, and then the exponent's the only thing that's going to change each time. And then I just copy all the numbers that are there until it gets to the decimal point, and I'm done. So it's not really anything that's going to be going too bad. So here's what I want to do just to help you out, because I don't want to go right till the end and say, boo, here's some work, go do this. And you're like, wait a minute. So here's what we're going to do. I am going to see how far I can get on this worksheet with you, doing like the odds with you, and I think I'm going to leave the evens for you to do. So what I'm going to do here is I'm going to pull this out of the way. I'm going to get the worksheet up here. Pull that down a little so you can see what I'm up to. And what we're going to be doing here on the front is just doing a little bit of look-sees. So like, here's how this works. So for instance, it says determine the multiplier. Okay, determine B. Because you're like, well, I don't see an A value. Where's A? Well, we don't have it. So if it says 5% growth, for instance, I would do 1 plus, how do I do 5% as a decimal? 0.05. Okay, that's all we're doing. So I do 5 divided by 100 if I wasn't sure what the decimal was I was going to add. So as I'm working down these,
Oh, that's all you have to do.
that's all we got to do for this part. I just want you to get used to figuring that part out. Okay, 30% growth, what would that look like as a decimal? 0.3. Okay, you could do 0.3 or 0.30. Doesn't matter. They'll get me to the same thing. But you got to watch the word. Okay, growth is going to be plus, ooh, decay.
So we do, I got something.
That's okay.
Oh, you're minus.
Yeah, this one's minus. Decay is always going to be minus, and I made a note of that up here to help you.
The growth, what'd you do again to get the negative? I mean,
The plus number, you always take the per...
the number, like the
This
0.5,
one?
the 0.5. Yeah,
Okay.
can you get that again?
You always take whatever percent they give you
Totally forgot.
and divide by 100,
Okay, no.
and that'll give you the decimal. So what's my 1% decay going to look like as a decimal? Okay, 0.01. Now here's the one that gets tricky. What when your percentage is a decimal? Here's where I still have to divide it by 100 even though it's a decimal. Ooh. So 1 plus.
How do you decay this?
So decay is the same idea, it's just minus instead of plus. Finding the percentage would still be the same.
Alright.
So like I'd do 1 divided by 100 if I wanted to find the decimal part on the decay for number 5. And then tripling, that one gets a little tricky. Because triple is how many times? Okay, so if it's going to be 3 times something, 1 plus what gets me to 3? 1 plus what gets me to 3? 2. Like, ooh, that's kind of weird. It's going to be 1 plus whatever gets me to that number. So if it's tripling and that's 3 times, I'm going to do 1 plus 2. No decimal to play with on that one. It'll be a whole number. So the other thing, I'm going to kind of preview this with you for tomorrow, because we're going to,
Number 2, please, like that.
well, is number 2 going to be a plus or a minus?
It's minus it, but I got 0.12.
0.12. Yeah.
What about number 6? Would it be 1 plus 3?
It would. Nicely done. Now when you get down to this next part, state whether the formula models growth or decay. Okay, this is how this works. If the number in parentheses is bigger than 1, okay, it's going to be growth. If the number in parentheses is between 0 and 1, it's going to be decay. And then there's even one more twist, and we're going to look at this tomorrow visually. If the exponent's negative, it makes it the opposite of what you would think. You're like, what? Okay, so number 11, for instance. 3. Last I checked, 3 is bigger than 1. So this is going to be growth. There's no other numbers to find. Okay, we just want to get to where we can look at the equation and say, ooh, that's going to go up. Ooh, that's going to go down. Now here, careful, 1.01. It's bigger than 1, but the exponent's negative. So you're like, crap, so this would normally be growth, but the negative flips it. And we're gonna visually look at this tomorrow. But just keep looking at that number inside the parentheses. And double check just to,
Like a 0 is decay.
anything, if it was straight up 0, well, I don't think we're ever going to get straight up 0.
And then it has a 0.
Well, between 0 and 1 sometimes we'll get. So like for instance, you may get something like number 19 here. You're like, okay, that should be decay because that's between 0 and 1, but there's a negative exponent, which makes it switch.
Yeah, I don't remember.
I know, we've got to keep some of you out of issues with the office so you can see this stuff as it's going on. You got to go back and check it out later. And the only thing as you get to the back, I'm going to move this again quickly soon, but we'll talk about some of these again tomorrow to kind of get you ready. We'll probably do the first couple and I'll have you do the last couple. So as long as you can knock out those evens on the front, you are in good shape.